So hello everyone and welcome to the iHub Summit 3 webinar series. For those of you who don't know me, my name is Marie Karekla, ERA's Engagement and Program Coordinator. Today's session on Integrated Design Studios is the first of the three iHub Summit 3 webinar series that will be taking place this week. Just before we get underway, if you've got any questions for any of our presenters today, please type them into the Q&A function that's located just at the bottom of your screen, and we will try and get through as many questions as possible in the time permitting at the end of the formal presentations. So now I'd like to pass things over to ERA's Chief Executive Officer and Chair of the Innovation Hub for Affordable Heating and Cooling, Tony Gleeson. Thank you, Tony.
Thank you, Marie, and thank you, thank you everyone for joining today. It's important before we start just to take a moment to consider on the lands on which we all meet. We meet right across Australia today, and in particular, I want to pay our respects to those of the traditional custodians of the lands on which we meet, the people of the Aboriginal and Torres Strait Islanders. I want to pay our respects to both the elders, both past, present and emerging, and recognise and celebrate the diversity of the Aboriginal people on the lands on which we meet. I'd also like to take a moment to thank ARENA, the Australian Renewable Energy Agency, for the funding for the iHub project. And it's interesting this stage where effectively 2/3 of the way through the project at this point in time, 2 years into a 3-year project. And really today we're going to be hearing about some of the outputs, some of the changes, some of the considerable value of what this project's bringing. And in particular today, I'd like to thank the University of Melbourne, being the lead project manager of this, project participants, which are from ERA, Arup, Oricon, Greenbox Architecture, Grimshaw Architects, as well as other participants from the University of Queensland University of Technology, University of Wollongong, NEXTDC and the ACT government. And as you can see from this, we've got quite a large group of people who are working away on these projects. I'd like to now introduce you to Brendon McNiven from the University of Melbourne, who's been leading the way on these projects.
Okay, so I'll just talk for a few minutes about what the Integrated Design Studios are before passing on to Lou and Dominik and Georgios, who we have here, who will take you through the rest of the program, what we've learnt about integrated design and some of the technical findings. So the integrated design studios are basically modelled off the architectural studios in the Faculty of Architecture, Building and Planning in Melbourne School of Design at Melbourne University. But they bring in engineering, and the idea is to study how engineers and architects interact. So there's 16 students overseen by a tutor doing designs of real buildings alongside clients, consultants and academics. And the idea is to do research on 2 fronts. On the larger, higher level front is to look at how integrated design happens. So how we actually better marry architecture and engineering so that we don't compromise either in the buildings that we design. And so better architecture means better built environment, better technical engineering content means better performing buildings and advances in climate, combating climate change, I should say. The second level of research is actually looking at the building typology. So we do this in these studios, looking at a whole lot of different types of buildings, anything from data centres through aged care. We're even going to look at some Indigenous type content around buildings as well. And at the end of the program, we hope to have a compendium of different building typologies and ideas around how we might do something a bit closer to zero carbon for each of those typologies. Next slide, please, Dominik. So this is how the studios work. It's set up on a win-win-win basis. So we invite clients into the studios and they get access to ideas about what their building could be. So they have 16 very bright engineering and architectural students thinking about what their building should look like and what should be in it. The consultants win because they get access to like-minded clients to work with. So it's a little bit of business development for them as well. You know, it's a real project. They're talking to real clients. They're also working with the university, which is a lot of fun, and they're getting access to some of the brightest students in the Faculty of Architecture, Building and Planning and Engineering at the university to really try before they buy. So, you know, looking at prospective talent, basically. The students get a fantastic experience because they're working alongside real clients and architects and engineers from industry. So it's as closer experience as you get to a design office while you're at university as you can get. And the university finally wins as well because we're doing what our remit is, which is research trying to make the world a better place. Next slide, thanks, Dominik. So Tony mentioned a few partners. We've expanded a lot because we're doing probably 2 to 3 studios per semester across the different universities. So that's a list of all of the different companies around the integrated design studios that are involved. So we've been incredibly fortunate to have people sign on and you know, believe in the program, and the feedback has been really good. So you know, we hope people would get a lot out of it, and it appears that they are. So it's been a very good academic industry collaboration. Next slide, thanks, Dominik. And this is the wider context. So the box you see on the left there is the actual studio. So that's the clients, the academics, consultants and students working for somewhere between 14 and 16 weeks through a semester to come up with designs and good ideas around zero carbon in buildings. What happens then in that second box is for another 6 to 8 weeks after that, the consultants, in particular the engineering consultants, take it on a little bit further and actually look at the feasibility of the ideas that they've come up with. So the design studios are very fluid environments. There's a lot of fast talking and ideas flying around. Some of them end up being great ideas, but some of them end up not being so great. So the idea is to let the dust settle at the end of the semester, look at the student work and actually identify the top ideas that can actually be taken forward. And then as you move further to the right, those ideas are up for grabs. The people involved in the studios obviously get first bite at the pie, so that's the clients and consultants in the main to take those ideas and hopefully develop them into ideas that end up in their projects, either in the projects that they're designing or in other projects they're doing as well. And so there's a little bit of IP around there. The IP is owned by the people developing it. But in reality, the ideas are very, very early ideas, and they need quite a bit of investment to take it through to something that's a commercial idea and you can make some money out of it. Yeah, and I think after a period of a couple of years, all of that information, in fact, even earlier than that, gets published and it's open to everyone in the industry. So like I said at the start, what we hope to have at the end of the program is a whole lot of ideas across a whole lot of different building typologies about how to get to zero carbon in the way that we design and build our built environment. Dominik, next slide, please. I think that's it from me. So I'm going to hand over to Dominik, who's going to talk a little bit about that high-level learning around what we've learned about architects and engineers working together. Over to you, Dominik.
Thanks, Brendon. My name is Dominik Holzer. I'm an associate professor at Melbourne University. I'm the research lead on this project. And of course, for us in academia, when we include this type of thinking into our curriculum, we have to be very careful because the dialogue between the architecture and the engineering faculties has to really work. The programming of these sort of subjects have to work because they're not, if believe it or not, they're not the typical types of studios or design environments that we have in academia. Normally you would see more distinction between what happens within engineering, what happens within architecture. But given the nature of the investigation here, it's obvious that here we put our heads together to come up with something new and something quite different. So there has to be, from a research perspective, but also from an outcomes perspective, there has to be a specific strategy on how to achieve that. There has to be a bit of a theory on how we set these things up. And at the start of the investigation, we put together a sort of we call it the catalyst for integrated design, a document that would help to guide us, that we are updating as we go. But of course, we are then collecting lessons learned also from the various activities that we're going through. So what I'm going to show you now is a bit of that framework and how it got together, and what we mean when we talk about integrated design. But then also, as we heard earlier, of course, there is now the time also to start to share some of the outcomes with you. And the outcomes are manifested in many different ways. The outcomes get manifested in terms of what we learn about integrated design. The outcomes get manifested by the projects that are actually produced by the students and how they respond to the integrated design challenges, obviously focusing on zero carbon sort of initiatives. And also, I think further down the track, what we will be discussing today with you is some of the actual sort of the engineering side, sort of the outcomes that we see. It's not just engineering, but some of the benchmarks, let's call them, that we see when it comes to some of the interventions that the students have been working on. So first up, a bit of an introduction to this catalyst for integrated design. As I said, this was developed early up front. In response to a number of challenges, we still see prevailing thinking in silos when it comes to different professions collaborating on projects. Integrated design is not the status, is not the normal sort of starting point for many construction projects that we see in Australia. And this is not an academic thing. This is obviously very much related to practice. Everyone would argue that they one way or the other integrate their design on projects. That's obvious, but some of the fundamental thinking that relates to those common goals is not always particularly obvious. So why are we looking into integrated design? Well, one thing that we've observed, and that's also related to this quote that you see here, this is from a very renowned architect, the leader of a design firm called Zaha Hadid Architects, where he argues, and this is Patrick Schumacher, in the past the engineers were far too subservient and keen, asking us, tell us what you want and we can make it happen. And I think what he then argues is that there is a change in attitude that's required. We want engineers to be more assertive and foreground the engineering intelligence rather than somehow, by whatever means necessary, realizing some preconceived form. This goes, of course, both ways. As much as he says that as an architect, it also means for architects that we need to learn how we share design authorship with engineers, how we work on concepts and ideas jointly, where the sum of individual bits is more than just these individual bits, but there are synergies and ways to improve what we're doing, and working particularly from big ticket items, from first principles, working with key challenges that face us in the built environment. And obviously carbon and issues related to carbon are one of the sort of maybe, if not the key topic that we currently talk about, and they are the perfect nurturous ground, if you want, for integrated design concepts to be discussed, debated, and that's exactly what we've done as part of this project. We should be aware, though, that we see a lot of different perspectives of the same issue. So you would have an engineer looking at something and seeing its beauty. You would have an architect looking at the same thing, not quite understanding the beauty or seeing things differently. So we do come from different professional backgrounds. We have our biases. We are being conditioned as early as academic sort of education. We're being conditioned in different ways of thinking. And of course, the integrated design studio is there as a test bed to see how we can work against that and how we can look at an integrated design process in a quite different way. So we realized, and this is now a bit of a sort of a feedback of what we are doing. We have these 12, 13-week semesters, typically at Melbourne Uni, where we have what we observed so far is that there is 3 key phases throughout the semester where we can identify that have quite an impact on the integrated design processes. The first one is the first, let's say, 3 weeks, the project inception, where we really get people together, where we form these groups between architects and engineers, cutting across architecture and engineering, where the project participants get familiar with the key sort of data associated to the project. That would include site visits and other sort of site location and client sort of feedback on what the client is particularly after. This is where the goals are being formed, obviously. Still very much in terms of integrated design, it's quite early days because there's still a lot of information that needs to be gathered about the project itself. And only once we get into what we label sort of criteria design from weeks 4 till 7, that's when you start to see some first potential for sort of integrated design to unfold. And then what we saw is refining solutions in weeks 8 to 13, where still, even in that sort of period, particularly weeks 8 and 9, we saw a lot of key sort of fundamental integrated design decisions being made, depending on which studio we've run. How many did we run so far? 6 of them. So depending on studio, from studio to studio, we see this sort of key criteria design and integrated design opportunities shifting from somewhere week 4 till week 8, 9 even, depending on the context. In our case, we then go beyond the week 13, we go another few weeks to do the project vetting. And as Brendon explained earlier, this is where then the engineering consultants come in, they take the most exciting student work, and they look and analyze how they can go from the business as usual to the an optimized sort of, particularly with a focus on zero carbon sort of solution, how some of the ideas generated by the students can be translated further. So to go through those phases, and again in a bit more detail, and what we observed and what's really important throughout these phases is really establishing trust among the project participants, looking at the limitations of traditional non-integrated design and removing those disciplinary barriers that you sometimes see. Being very clear about the assessment tasks, both individually for the students, because architects and engineers tend to get assessed differently in their courses, but then also try to understand what are the joint sort of assessment tasks that we could see. Empathy, this is where we then start to form these groups, where we start to get each individual sort of discipline realize where the others come from and what the key hurt points are, or the key success points are of the others. Really then discussing also the expected roles of the participants and explaining the process that we expect them to go through. Once we go into the criteria design, we really emphasize on the idea that everyone is a creator or co-author. It's not, as we saw before with Patrick Schumacher's point, that we have the architects just doing the design and the engineers responding one way or the other and in some sort of empathetic engineering. But we really want a strong engagement between the architects and engineers, feedback loops with ideas being generated on both ends jointly in these iterative processes. When it comes to sort of the carbon aspect, we would prioritize the passive solutions before active, and instilling into the architects the sense of and responsibility, if you want, even what some of the basic decisions that they make, what impact that can have on the overall sort of performance. And of course, the engineers are a pivotal part of that as well, looking at common targets, and also discussing solutions on the fly in this sort of co-rationalization environment. We need to introduce, and this is something we also saw with the engineers, we need to introduce educated guesses and people becoming comfortable with educated guesses, which is what we saw not always easy for engineers, which is a bit more easy for architects because that's what we are trained to do. Now in week 8 to 13, the window of opportunity to actually have come up with integrated design solution really starts to shrink the more you get towards the final outcomes. That has to do with, obviously, those of you in practice would know about this, the deliverables in terms of submissions. So people focus on the end result, people focus on what they have to submit. And that's where you start to narrow down solutions dramatically towards the end. So here, though, it's really important that there is then more focus on the more sort of precise articulation of the environmental solutions, focusing on the human comfort, focusing on active and passive solutions and their detailed sort of exploration, working with end user performance metrics. And we've also started to introduce computational tools and scripts that would help the students to work towards very specific goals, particularly when it comes to carbon. And yeah, really ensuring that the design remains really a multidisciplinary effort that works across different aspects and where you can tell the integratedness of solutions that are being found. Now, from that period then, in the vetting process, really taking further best ideas, looking at the most innovative solutions, looking at benchmarking data, and as Brendon already mentioned earlier, then developing for any specific building typology a carbon catalog to take things further. Of course, then for each of those vetting exercises, that there's a report being produced by the engineering firm that's involved in it. And that report then feeds into the wider knowledge sharing that we're doing as part of the iHub IDS projects. Some lessons learned, and I've only put together, I think, 3 slides to talk about this in a bit more detail. So really the formulation of common goals, and I did speak about that earlier, is absolutely crucial. And they have to be equally relevant for the engineers as well as for the architects. I mean, there were some surprises that we found out when we considered our lessons learned. Obviously, the more obvious ones would be that you have to be very explicit when it comes to the deliverables and the goals for each discipline, then ensuring the alignment between the different disciplines and their goals. But one aspect that we found out, sometimes it might actually work to establish integrated design extremes. So what if you had a pure architectural design, focused design? What if you had a pure engineering focused design? And sometimes pushing these extremes and presenting them to the students or asking them to engage with those extremes was helpful for them to understand sort of where the others might be coming from. So that was one technique that seemed to be relevant in some instance. But also introducing smaller tasks in specific areas and looking at sometimes breaking down the bigger, larger common goals into very clear and clearly achievable sort of subcomponents to bring the individuals together. The next one was a focus on creativity and innovation, where you have to be clear that if you focus on too tight or too many deliverables, you might over-constrain, at least in our 13-week design process, the ability of the students to explore novel ideas. And you really need to get the timing right. As I said earlier, when I discussed the phases of our 13 to 20 week sort of investigations, if you come in too early, you will see that a lot of the students are not quite ready for that sort of integrated design process. If you come in too late, the window might have closed because they start to focus too much already on working on towards their deliverables. So some of the key lessons learned is really that we need to consider the level of experience of the individual designers. When we had engineering consultants come in and talk to the architects in some of the early iterations, we found that the architects had to really pick up so many new nomenclatures and ideas. They were not familiar with design towards specific performance goals, so they had to become familiarized with that. Of course, architects and engineers have different preferences in communicating and engaging, so we need to understand sort of that sort of personal cultural background as well. The integrated design iterations happens in this sort of limited time window, as we pointed out earlier. And clearly what we also realized this last semester, where we are fortunate enough to teach a studio entirely face-to-face, that the sort of face-to-face interaction, at least intermittently, is still kind of the gold standard for achieving integrated design. It was definitely possible to talk and discuss integrated design if you work remotely and using these online tools, but we could really see the social bonding and the way the dialogue was unfolding was quite different and was better once we had opportunities for the students to catch up face-to-face, in addition to also working online jointly in their groups and teams. The last point is about balancing individual and integrated approaches, and also both in terms of the architecture engineering, but also in terms of how creativity can unfold and how to facilitate this sort of collaboration. So here again, some lessons learned is that a base level of understanding is required in the disciplines before integrated design can happen effectively. So going back to what I said earlier, it's really important that the students understand what they're expected to do, but also what the others are expected to do, and be knowledgeable about, when we talk about particularly environmental design, about those benchmarks, be knowledgeable about the key goals and how to express them and how to, in their design process, how to pursue them. And we needed to educate designers about the process of developing an understanding of the fundamentals before experimentation could really occur. So you can't expect anyone to integrate and experiment when you don't have the basics yet. So we really needed to cover the basics early on. So we had, in those studios, we had a lot of presentations from the engineers, from architects. We were introducing them to the benchmarks and so forth. And of course, then throughout the semester, you need to ensure that you actively curate the architecture and engineering collaboration. So it requires this sort of active curation. It requires input from the studio leaders and from both towards the students, but also towards the collaborating sort of consultants who were part of that sort of process. And I believe this rounds off my part talking about the sort of the framework itself and some of the lessons learned. I think the next part, we're going to start to introduce you to some of the sort of findings that we had from the projects that they were looking at. In the first few iterations, they have been looking at school buildings, they have been looking at an ambulance station, they have been looking at a data center, and they've been looking at an aquatic center. I'm going to introduce you to, and that was the part of Melbourne Uni, and I think our colleagues from Wollongong will talk about some other typologies in addition to that. Yeah, some key sort of points here when it comes to some of the learnings in relation to school. We were undertaking the school projects predominantly, actually exclusively so far in the ACT, where there are very specific climatic conditions with the summer heat loads and cool sort of winters. So there had to be a very fitting response to that climate context. In many instances, because these were school refurbishment projects with some of the schools dating back from the 1960s, if not older in some instances. So we had to look into the building envelope and particular passive options to increase the performance of the building envelope. Sometimes orientation was also then a question and so forth, windows, roofs and so forth. But also then looking at some of the more sort of mechanical aspects, looking at air source heat pumps and so forth to help facilitate a better sort of performance. You can see some of the proposed initiatives. I'm not going to go through all of them. I think it would take too long, but you can see there were both passive measures as well as active measures that were playing into this. With the schools projects, yeah, so as you can see, this would be one example of the student work that you can see here, where the students would look at a tool called Safara. Maybe some of you are using this in practice as well. And so looking at the sort of carbon context in a very holistic way, looking at how the different interventions, and in this case, there was also some daylight analysis that was done, how the different interventions can actually contribute to the overall performance and the overall picture and carbon reduction. And these sort of early student sort of works were then examined further by the collaborating, and this is another example coming out of Safara, I think, yep. And yeah, how some of these were then translated into more sort of solid sort of benchmarks by the participating engineers. I think this is just another example of one of the school examples. So it's really, as you can see, the students and being architecture students, initially they would not have been exposed much to these sort of processes. And I think the studio gave them, and of course collaboration with the engineers gave them far deeper insights in how to approach this and how to change their architecture thinking. I'm not sure any of them will become experts in zero carbon, but I think what's really crucial here is that the students start to talk, understand the language, understand the sensitivities, understand how very fundamental decisions they make have an impact on the overall carbon emissions that this project might ultimately bring along with it. And so they had this continuous feedback throughout the semester about these issues. And then last but not least, here's just some examples from Jacobs, the vetting project to look at the energy use intensity and some of the sort of, for two different school projects that were looked at, some of the key benchmarks that they were finding in this particular context here. So moving on from the schools, we had the ambulance station, and we had Atelier 10 join in the studio quite actively throughout the semester. And we looked at, they looked at sort of potential for carbon reduction. I think they came up with up to 50% energy savings compared to business as usual that could be achieved with the sort of initiatives that were proposed, again, some of which I list underneath, some of them obviously being passive, some of them being active. You can see here some details. So that's one of the students' project, as you can see here, for the ambulance station. And I think it's really an interesting sort of process that we observed how the studio tutors who would have taught these sort of studios in the past, but not necessarily having that focus on the environmental aspects and on zero carbon, how they also had to go through a learning process to understand how they should weave these sort of requirements into the typical way that we would normally in the architecture school, in education and higher education, how we would introduce these issues. So a lot of conversations about photovoltaics, a lot of conversation about passive measures. So you can see here some examples here. That was one of the final outcomes here. And another one here. Again, as I said earlier, really introducing that sort of thinking about airflow, about different sort of facade materials and the performance, about the roofing, about orientation, all of that sort of introduced. And in this particular studio, Atelier 10 also shared with the students a script that they had developed that plugs into the software that the students are using, and I think into their daylight analysis. It was this passive house tool that helped the students to explore a bit further and come up with these benchmarks ultimately that then Atelier 10 was sharing with us about against again, these sort of opportunities. Okay, at this point, I believe I'm going to hand back to Brendon, who will be talking about the data centers.
Thanks, Dominik. Yeah, so data centers was one of the first typologies we looked at, and this will be fairly quick because I must admit I hadn't realised, probably my background is structural, but you know, just how much power data centers actually chew up, and it is huge. So even looking at all of the renewable options and generation options, the generation on site that we could come up with was somewhere between 1 and 2.5% of the total site power usage, looking at facilities between 80 and 20 megawatts. So what that means for data centers, unfortunately, is that it's never going to be core business for them. You know, a 1 to 2.5% option on a project is always going to, you know, not be agenda item number one, I guess. But you know, 1 to 2.5% of a very large number is still a very large number, so it's worth doing. And it was great to have NextDC on board, and Greenbox and Oricon as the consultants, and they're all, you know, experienced data centers designers, and totally committed to doing better on the energy front. One of the really interesting things that came out of it, and next slide, please, Dominik, was that, and if you could just go through the text as well. So, yeah, looking at modelling it, the amount of waste heat that's available around a data centre is incredibly large. So it makes sense to set up some adjacent uses that can actually use some of that waste heat energy. And a lot of the uses that the students started to look at were swimming pools and greenhouses, both of which had very high energy bills at the end of each year. So I think that the average energy they were looking at, 7 million megajoules, is only about 0.3% of the total heat rejected from a data centre site. And what that means is that it actually opens up a different business model opportunity for data centre operators. So data centre operators, there's a few of them around. It's really big business, there's big money involved, and it's high competition. And so that competition extends to the sites in different suburbs where they're located. So in competing for a site in a particular suburb, it actually makes a lot of sense, we think, for a data centre operator to talk to the council about what other buildings they've got planned. And you can come up with a community centre that might have a big greenhouse in there and a local vegetable market garden, or you know, an aquatic centre or something like that, and actually link the two facilities together so that one actually pays for the other in terms of the energy bills at the end of the day. And that gives the data centre operator an edge over their competition, and hopefully improves their business model. These are just a couple of the images. So the students did a lot of work looking at the data loops, you know, the energy loops, and where it was going. Next, please, Dominik. There's one very solar intensive solution, and the next one. Next slide, thanks, Dominik.
Got stuck. Here we go.
Oh, there we go. And this is the last slide. This is one of my favourites actually, because it's just reimagined what a data centre could be for looking at modular construction. And this was partly came from Peter Greaves at Oricon, who had this in the back of his mind for a while. And you know, the integrated design studios, you know, give them an opportunity to explore some of the good ideas that they've been waiting to explore outside of the project environment. So the great thing about a modular data center is you can build it small to start with, and it can expand in time as you need it. And then as technology changes, as the data banks get more efficient, you know, don't need less heating, can do more, you can actually just slot these things in and out and update the technology with time. So this building is all about craneage and access and being able to self-construct and then be able to self-update on the way through. Okay, that's it from me. I think now we're passing over to Lou from engineering. He's going to tell us a bit about aquatic centres. Lou.
I'm Lou. I'm Professor of Energy Engineering at Melbourne University. And my apology, I'm running a bit late. I was having COVID vaccine, so I just had it. I've done my part. So let's look at Aquatic Centre. They have a different from other buildings. They have a unique requirement, and they do have a, as you know, wet and dry zone. And some of them, they operate continuously, and they got to heat and then maintain the temperature of the water. And they also need to do the disinfection for health purposes. So there are a lot of opportunity there. And the most, what we call important one is a daylighting. And when we do daylighting, as you know, we need to compromise with the daylight. We don't want a lot of heat loading, depends on what we call the system. And there are several other options you need to look at, and the orientation of the vision class. And you want your, what we call swimming pool seen by other, or you want your exercise, you know, regime, look at the outside view and those sort of things. And we also need to minimize the air infiltration. There are several opportunities there. The picture at the bottom is one of our students, what we call design, providing balancing between daylighting and then plus cooling load. And then that's the one. Next slide, please. And students look at St. Gilda Triangle project. And the requirement for them is that they must have the indoor pool, outdoor pool, and the dive-in pool. And they also need to have a cafe and the gym, and then park. You know, they also must have offices and shop for the, what we call public to use them. So these are several options provided by the consultant, and then students looking at those options in detail, and they do come up with the number at the end, and they do come up with the, you know, design. And this is a collaborative design. In that first semester, architecture student and engineering student collaboratively design that. And the design is a conceptual design. And next semester, following at this moment, what they have done is that they have done the, what we call detail analysis of those options and then comparing in detail. And that one, they just submitted today, so that should be available after this. Yes. Next slide, please. And we have looked at the baseline, current best practice and future. This is out of our, what we call bedding report. And as you know, electricity use, gas use, and then requirement for the insulation and the glazing and infiltration. If you look at baseline, these are the current baseline, you will notice these are kilowatt hour per meter square per annum. So these are relatively about 5 or 6 times more than other building, as you can see. That's a baseline one. And we are trying to shift away from gas, as you know. So future, what we are expecting is that we will have less gas use or electric. That's a plan. There was a what we call recommendation, and that's what we found. And the baseline insulation, it's a 3.5 for, you know, R for walls and a 4 for roof, and this should be improved for the current best practice, and this has been improved in the future. And if you are building a building in what we call Victoria in Australia, we need to meet the NCC requirement. So baseline is the NCC requirement. So the current best practice is doing better than baseline. So the glazing, and again, you need to be careful with this number in there. Number is for the design in Melbourne. It means it is Melbourne is what we call heating dominant climate here. That's why what we want to do, it's different from other things there. Yeah. And the infiltration, as you know, we should reduce the infiltration there. Yeah. Next, please. So key features, if we look at those, and these are building envelope, as you know, we should focus on building envelope. And so insulation and construction technique for high performance glazing, and then air tightness are required. So building envelope is one of them that we should look at. Another one is, as you know, electrification. Mainly in Victoria, we should look at electrification, our heating relying on gas. So that's electric heat pump, electric heat pump coming. And we could also think about the storage solution there too. And as you know, smarter control strategy, these are all available now off the shelf. So we need to apply those in air distribution and temperature and humidity control and water, and then other, what you call filtration and disinfection. And there are several design performance metrics there. If the client set those from the very beginning, that will help meet the requirement. I think that's all from me. Thank you.
Hi everyone, I'm Georgios. I work at the University of Wollongong, and today I'm just going to present you about 2 integrated design studios that we are currently running here in Wollongong, with a lot of help from the guys in Melbourne as well, who helped us a lot to get the studios on the ground and start with the projects. This is really a 50-60% progress presentation, really. We are meant to complete those by October, November. And the first studio that I'll talk about is it's a community center, a library community center near Wollongong that is owned by Wollongong City Council. So the client is Wollongong City Council, and in this case, the council wanted to look into how to meet their net zero emissions target by 2030, because the current building is due to be upgraded. So they wanted to get ideas out of the IDS. Again, same story as in Melbourne. We mix students from various disciplines. We got architectural engineering, we got mechanical, civil, environmental, and we had consultants from structural engineering background, ESD consultants, and architects. And in our case, we had a hybrid delivery. Next slide, Dominik, has just a better picture here of the hybrid delivery. Most of the students came to the class, I don't know, 80%, 70-80%, but some students and consultants were online, and we were lucky to have a very well-equipped room with very sensitive microphones, cameras that move around, and so on. And this worked very well in our case. And the second design studio was an aged care facility, or is an aged care facility, at the Health and Wellbeing Precinct at the Innovation Campus of Wollongong University. And the client in this case was Lend-Lease. The purpose of the studio was to look into ways of minimizing use of natural gas and moving towards low carbon design, but of course by taking into account thermal comfort and cost. Next slide, Dominik. So the studio started by having the client by the students providing a return brief to the client. They've done a site analysis for both sites, and this is only a small sample of the outputs. There are a lot of very good outputs out of the studios, and the clients are very pleased with what they have seen so far. They looked into doing a benchmarking exercise. In this case, for example, it's how the building, the library building, the community center building performs in relation to neighboring libraries that the council owns or other councils own, and where they want to get to, and how far are they from their targets. Next slide, Dominik. Thank you. And the second part of the studio involved developing a matrix of all possible design solutions that the students can come up and start ranking or grading those solutions against criteria such as feasibility, cost, energy saving potential, carbon saving, innovation. Innovation was very important. And they didn't have to undertake a very detailed design analysis for those ideas. They just had to either do a back of the envelope calculations or go through catalogs and industry publications to find out and rank them accordingly. So group work again, and a lot of design concepts, as you can see here. We had about in total 120 design concepts that the students came up with. Next slide. Again, this is just a small sample. Many tables like the ones I showed you were produced. Then around the end of the semester, we asked the students to undertake, together with the help of the consultants and the academics, to undertake a bit more detailed design analysis and looking into some of the previous ideas that they had to quantify a bit more those ideas. And what we noticed that a lot of the students went through the easy route. They picked solutions that they are relatively easy to either model or calculate or talk about, such as shading devices and changing windows and so on. But there were some really good ideas that, again, that they were produced. You can see here, for example, they took they looked into how we move into future parkings with carports around, what the benefit may be. There was also a component around standards and rating tools. So they looked into Green Star, for example, how the solution will help meet some of the Green Star requirements. Dominik, next slide. So some initial observations. Again, Dominik touched on that earlier on. The architects and the engineers have a very different perceptions of what they can do and what they cannot do, and where their boundaries stop, really. So there was a perception, for example, for the students with architectural background, that they don't even want to discuss anything around systems in the class. They just can't do it, or they can't participate in that. But that changed over time, while the engineering students were more into a calculation mode, if you prefer. They just give us the design and let us put it in softwares to get some numbers out of those. Can you click again, Dominik? Yeah. The framework we put forward to the students really helped them produce a bit more than without giving them any guidance. Do a site analysis, look into benchmarks, develop a matrix of all the concept designs, and then select some of those to do some detailed calculations. Next one, Dominik. Feedback from the client on the return brief was very, very important, and the consultants having structural engineers together with EST consultants and students from different backgrounds was very useful. Some ideas were not feasible, for example, from the structural point of view, but were much more easy to be modeled, or they had to be altered accordingly. Again, they did this. We noticed that a lot of the tools we made available to the students, such as online forums, drop-in sessions for talking to consultants, they were not fully utilized, and those could be better utilized in the future. And then in one of our projects, as I mentioned, it was an existing building, and that was a little bit different than the typical design of new buildings. As you can imagine, there is a bit less flexibility on what you can or you cannot do with existing buildings, especially around the geometry of the building. But on the other hand, there are some solutions that, as we call them, the low-hanging fruit solutions, that they are possible, LED lights and the likes. And with existing buildings, you have the advantage to be able to talk to the users of the building. So during the site visit, there were several occupants who we had the chance to talk to them, and it was really interesting to see the insights we got out of that when it comes to the heating, ventilation, and air conditioning system, and the thermal comfort of the space. And finally, in the end, one thing we should have implemented, I guess, and perhaps in the future, we should have that if we ever deal again with existing buildings in studios. There is an option to do spot measurements around the studios, even without instruments. The phones now, there are apps where you can measure acoustic parameters. And they work really well. The daylight apps are not that good, but again, instruments that you could use to look into daylight in the spaces are fairly straightforward to use in these studios. So that will give extra insights for the studios. And that's it from me, Brendon. I guess I'll pass it back to you for questions.
So that first one there from Lyndon, what role does the client have in the shortlisting process for the ideas to progress? Actually, the vetting process in terms of identifying the good ideas and not so good ideas is more about the technical performance of the ideas, so that the client doesn't get as heavily involved at that end of the process. That's more the technical consultants, so the engineering consultants looking at that with the vetting reports. But the client has an active involvement the whole way through the studio. So in particular at the front end in the first couple of weeks, they are preparing the brief or developing the brief with the students, and then presenting their business model and their thinking, and then they come back in mid-semester and they critique the designs and input into the designs at that stage, and then the same at the end of semester they also critique and are part of the final judging panels.
I would add that it's quite a useful reality check for the students to. And I remember the sessions we had with the data center. It was quite interesting, where I think it really increased the quality of not just the conversation but also the design. Ultimately, where at mid-semester the client came in and just told the students all the things that wouldn't work, and that's great, because you don't as an academic institution, we don't aim to just do 100% projects that then get built. We do have the need to experiment and to try something new, and the client actually wanted that. And it was interesting to see that tension between the experimentation that was desired, but then also the reality check of things that just wouldn't work. But the students wouldn't know normally the reasons behind any of that, but having the client in the room, they would then be getting that feedback and they could adjust their design, still being quite experimental and out there, but in some areas where things just were done because they didn't know any better, they could certainly change that and increase the quality of the designs quite dramatically, without compromising, if you want, either the performative aspect nor the aesthetic aspect.
Okay, thanks. All right, the next question is Gareth on heat pumps and data centres. There's a lot there. I think they're very good points, Gareth. And Lou, you might be better placed to answer this one, but my understanding is that the waste heat from data centres is a low-grade heat. Is that right? So you can actually take energy out of it, but it needs some effort, or it needs some forward planning, and that probably speaks to your comment about it would be improbable that they would be co-located. I guess the concept is that there's waste heat to be had there, and it's about actually trying to start the design off on the premise that you're going to use that heat in some way, in a useful way, rather than actually just go and get the most efficient data centre you can without considering the wastage along the way. So the students obviously were trying to look for community benefits. The idea is that our data centres are community assets, and so they started to look at other empathetic uses like the greenhouses and swimming pools. But you might be right. It might be better to develop data centres and actually just put all of that heat back into the grid in some way. Lou, do you have any thoughts on that as a...
Yes, district heating is a very good idea, but we haven't got the culture or the tradition doing in Australia. If you look back Europe, district heating is happening a lot. So there is a big potential for precinct level heating and those sort of things. Maybe we try it out in the Fisherman Bend, maybe 5 years time. Melbourne Uni is building buildings there. So this is one of the options. If we have I'm sure we will have a data center somewhere to have our own data, what we call store. Yes.
I thought there was one more question about, and that was for me, about the overall goals that were communicated to the students. So I think in that regard, there were two things. There was a combination between the design goals that would have been expressed by the studio leader and the goals towards sort of integrated design and zero carbon that we had then injected into the studio. So we were sitting with the studio leaders and the client in the weeks before the studio to help define the studio program. And we didn't want to overwhelm students from the start with too many constraints, but we very quickly in the first and second week, by introducing what this particular integrated design studio concept was about, we started to introduce more specific carbon goals to the students in those sessions. And that was a pretty successful sort of program so far, from what I can tell. So there were some clearly identified goals when it came to the design in general, but then some more clearly defined goals, again, studio by studio, changing also depending on what the client was after and what we were hoping to achieve, looking at the carbon aspects and the building performance aspects. If you do a refurbishment project, obviously your goals will differ from a complete sort of new build. And again, typologies will also have an impact on what those goals are. If you talk about an aquatic center, it will differ from a data center and a school and so forth. But yes, overall, I mean, it was really a conversation we had to have with the client also. So it's important that the clients get their benefits from these processes as well. And so that's how some of these goals were formed.
Yeah, so thank you for that. Presenters. So that is all the questions that have come through. So that will wrap up our Q&A session and bring us to the end of today's webinar. So I'd like to thank everyone who registered and attended today's session. A special thanks goes to our presenters, Brendon, Dominik, Lou, and also Georgios for providing us with an update on integrated design studios to date. As I mentioned earlier, today's webinar is the first of the 3 iHub Summit webinars taking place this week.